Hey guys, so obviously you see that I'm not here today. I'm actually out at a conference day. So with that, left you with the virtual towers lesson. No, we haven't had one in a while. So with that, we're going to continue our work with our trig equations. And this time we're going to work on the second degree variety or a quadratic variety. All right. Before we get to that, just a couple of reminders for your week. Homework tonight's attached to the packet that you're working on with me here. And this Friday, we'll have our test on our trig equations. Again, we're only going to be doing a couple of days of this, so we'll take care of all of it by Friday. All right, so with that said, basically what we're going to do is deal with quadratics like we've done before. As you guys see from the example here, if we were trying to solve this quadratic, as you all know, we would be setting it equal to 0. And once set equal to 0, we can factor and solve for each value of x that designate the roots of our quadratic. And as we know, these would be our solutions for this quadratic equation or second degree equation due to the fact that we have something squared. Nothing new that you guys haven't seen before. Well, if you can do this, you can most certainly do this. Once again, hopefully you guys are making the comparisons like we did last Thursday in first degrees. But what you see on the left with quadratics in algebra, it's basically and exactly the same as what you see on the right with our trig equation. The only difference being, as we saw with our first degree equations, is we're going to go back to the calculator in step 2, doing a little inverse trig to make sure that we get the angle values for theta in the end. So first step, set it equal to 0, factor and solve like usual. And then second part is going to make sure that we solve for all the angles that make the equation work. All right. What I'm going to do for you guys is model a couple of different varieties of these, some with different factoring skills so you kind of get the general idea. And then you're going to spend the rest of the period working on the remaining examples that are in your packet here. So if you guys could, please turn to example number 2. All right, so with this example, guys, obviously we see the layout and we see our equation set up right here, and it's already set equal to 0. Now, I know this one's not specifically a second degree because you don't see the squared, but before we get to that, I do want to share one thing with you about this example that we haven't seen in the past. As we know, whenever we're set equal to 0, we can look to factor and solve. And if it helps, as we saw before, it might be easier to turn this into a more algebraic setup so that it's easier to visualize the skills we're going to need. But as we mentioned the other day or last Thursday, if we are going to do such a thing, we need to replace those variables and state a key of what they represent. So C is cosine, S is sine. The reason I wanted to show this one to you guys is because if you notice, the factoring skill that we actually have to do here is GCF work. So just because it's not a typical trinomial to factor, we can still factor and solve with our other factoring skills instead. Now from here, we can actually tee off and solve, but before doing that, we want to restate what those variables actually mean. So what we've found here is that cosine of x is going to equal 0. And then the other side, 1 minus 2 sine x is going to equal 0. Well, the only one we really have to solve here is the sine version. So we're going to subtract that 1 to the other side. We're going to divide both sides by negative 2. And we get sine to equal 1/2. And now the calculator comes in. All right. For the step on the left with cosine, notice this is our exception to the rule. So here, we're going to use a little unit circle work to find the values of our angle. So our key points of 1, 0, 0, 1, negative 1, 0, and 0, negative 1. As we know, cosine is really an x value. So what x values do we see that are zeros? Well, we see that at the 90 marker and the 270 marker. So for this guy, x is going to be equal to 90 degrees or 270 degrees. Oops. Sorry, guys. All right. So we've solved for the values on the left side. We're going to do the same thing on the right. But here, we have a value that's not the exception. So we're going to work the calculator. And since sign is positive, we know we're going to need solutions in the first and second quadrant. So with that said, calculator out, and a little inverse trig. Second sine 1/2. We get 30 degrees. So as we know, that 30-degree angle is our quadrant 1 answer, and it works as our reference angle for our quadrant 2 answer. And there you go, guys. There is the gist of your quadratic setups or second-degree setups for your trig equations. All right? So any factoring skill that's necessary, we're going to clearly do. This one involved GCF. The one that follows in example number 3 is clearly a basic trinomial. So to quickly blast through this one, as we have shown many, many times before, we like to, or I like to, change these into a more algebraic setup where possible. And again, if that helps you guys out, by all means, please do so. Here, standard trinomial. So when we factor it, we get s equals 2, s plus 2 and s plus 1 as our factors. We're going to solve. And as we know, s really represents sine. So we're going to rewrite it in our answers or our roots in their trig form and go to work. Once we get to here, calculator comes back into play. Now the first part, the sign of -2, if you guys go to your calculator and put in inverse sine of -2 and you hit enter, you'll notice you get this domain error. And that occurs because there is actually no solution for the left side. So when that happens, we actually can reject that part of our work. There's no value or no angle that actually creates that situation. So that piece can be rejected. But the other side, we definitely know there's a solution for. This is our unit circle work. Again, the exception to the rule and the use of the unit circle is what will get us our solutions for this part. Key values once again. As you guys hopefully remember, sine equates to the y value on the unit circle, and the only angle that has that situation going on is at 270 degrees. Thus, the only answer here is 270 degrees. So hopefully, guys, you are seeing how easy these questions really are. Again, your algebra skills of solving basic quadratic equations are what come into play. And then that last part of just tying in our skills of finding angles, whether it be through the calculator and reference angle work, or through the unit circle, depending on what type of values we get. Before we close it out and you guys get to work for the remainder of the period, I do want to show you one other scenario, one other factoring skill that you will be responsible for, and that occurs in example number 7. So I'll give you a second to turn to it. And in this case, guys, if we take our second-degree trig equation, or our quadratic trig equation, and rewrite it in its algebraic form, and as we've said, not mandatory, but I think helps many of us visualize exactly what needs to be done with the algebra here, and remember to put your key. Hopefully you guys recognize that this is actually a bridge trinomial. In order to factor this guy, we're going to do a little bridge work. And in this instance, we're going to get that -2. So we're looking for two numbers that multiply to -2, but that combine to the +1 that we see next to our C. And from there, we're going to reconstruct this trinomial into that four-nomial form that will allow us to factor it by grouping. So really just wanted to show you that situation. Again, whatever factoring skills come into play, we must use, but then we will solve accordingly based upon what factoring we need. We've seen GCF, we've seen regular trinomial, and now you see the bridge trinomial coming back into play in the question we have here. So if we finish up our work and we factor by grouping after creating our bridge, we now have our setup with our two factors. We can set them equal to 0 and solve accordingly. At this point, we get cosine theta equaling 1/2 for our left side root. And on the other side, we get cosine theta equaling -1 for our right side root. And at this point, guys, your calculator skills are going to take over. And from here, to put all your final answers together, you're just going to make sure that you do your quadrant work. For this left side answer, we're going to be in quadrants 1 and 4. And for this guy here on the right side, this is our unit circle exception to the rule. And again, you guys can finish that one up on your own. But from there, hopefully you see how easy these equations really are. Regular standard form quadratics, set it equal to 0, factor and solve. But your final solution, once again, is going to be that angle value that we find either in the calculator or with our unit circle. With that said, you have the rest of the period to be working on all the remaining examples. You may work together in your small groups as you guys usually do. Don't forget, test on Friday, and there's no weekly review for this week since I was not here to see you guys on Monday. Hope you guys have a great rest of your day, and I'll see you guys tomorrow.